Assalamualaikum. Good evening. My name is NAUFAL, and today I will be presenting about discrete least square methods and how we use it to determine the area of a lake as the area of the lake. The lake that we choose is the lake that is at section 7 Shah Alam. So first we need to explain what is discrete least square. Discrete least squares is used to estimate the area of a lake when its boundary cannot be described exactly. First, the coordinate points are extracted from a Google image along the top and bottom edges of the lake. These points are then fitted with smooth curves using the discrete least square methods, which minimizes the error between the data points and the chosen mathematical model. Once the best fit curves are obtained, calculus is applied to integrate between them, allowing the approximate area of the lake to be calculated accurately. So this is the image of the lake that we use, which is located at section 7 Shah Alam. The reason we use this lake is one, it has very uniform shape, so it's easy to redraw it on a graph paper. And second is it doesn't have a lot of straight lines, which reduces its error. Now after plotting the shape of the lake onto a graph paper, this is what we will get. Along the y-axis, it is labeled from 0 till 45, and along the x-axis, it is also labeled from 0 until 65. Now, as you can see on the graph paper, we put a few marks on it to show the proper points that we use to do our calculations. Now for the top curve of it, the first x that we use is located at 10, at 30, and 50. For the y, first is 27, second is 36.5, and the third y is at 32. Now for the matrix, we plot it like so, and then in order to find the d using the diagonal method, we just calculate it using the matrix, and we will get the d value. And after getting the d value, we can find each a, b, and c. So this is our a, which is negative 0.005, b is 0.175, and finally the c is 35.75. Now fx, after getting all a, b, and c, the fx for the top will result in negative 0.005x squared plus 0.175x plus 35.75. And now I will pass it to my groupmate.
Okay, Assalamualaikum. Now I'm gonna explain for the button curve. So for the button curve, we got the point is 55 tenths, 35 9.5, and 55 3.5. And then we're gonna use this matrix formula to get the A of negative 0.006875. Okay, for the B, we use the same approach, which is matrix, and then we got 0.31875, and for the C it's 6.7656. So for the fx button, we got negative 0.06575x squared and plus 0.38175x plus 6.6756. Okay, so for this part is we calculate the area. So this is for the top. So we use 10 until the limit is 10 until 50, and this value is for the upper limit 50, which is 1797.917, and this is value for the lower limit 10, we give 364.85583, and the total area that we got is 1433.33 units square. And for the bottom, we use the limit 15 until 55. So the upper limit 55, we got 472.94, And for the lower limit 15, we got 129.61. So for the total area, we got 1090.00 units squared. Okay, for now, we're gonna calculate for the errors. So for the first one, we're gonna calculate the exact value, which is 231 boxes times 25. 25 comes from because of my square is 5 times 5, so which gives 25. So we got the 5,775 units. And then we're gonna calculate the absolute error, which is which is the exact value minus calculate value, give us 4,385 units squared. And for the relative error is 0.8113, and for the percent of relative error is 81.13%. Okay, for the conclusion, from accuracy, the discrete least square model provides a smooth mathematical approximation of the shape. And from technique, it combines the metric algebra and integral calculus to estimate area.